Hello, my dear students. How are you? I am Dr. S.K. Das from Regional Institute of Education. Once again, I am standing before you for the live interaction of an interesting chapter, Motion, of your class, which is in the NCERT textbook. We have already completed 5 classes, and let us see what we have learnt in our last class. So, we have learnt about rest and motion. Then we learnt rest and motion are relative. Then we learnt types of motion such as linear motion, circular motion, rotational motion, and vibrational motion. Then we learnt about distance and displacement of an object in linear motion, of course. Then we learnt uniform and non-uniform motion of an object in linear motion. Then we learnt speed, then velocity, then we learnt about acceleration. Well, let us see what we will learn today. So today, first of all, we will learn about the graphical representation of linear motion. We have already studied linear motion. Now we will see how we will represent linear motion graphically. So that is the first learning point today. Then we learn distance, time, graph in linear motion, of course. So these are the learning points today. Well, so before we start with the first learning point, that is graphical representation of motion, so let us see this picture. What does this picture indicate? This picture indicates a real graph paper where we need to plot a graph. This is the graph paper. Is it okay now, students? You must have used graph paper in mathematics, and also you must have drawn several graphs like bar graph, like pie graph. So many types of graph you might have drawn in mathematics. But this is the real graph paper where you will be plotting your graph. So then, from this graph, what is your observation? You must have used the graph. So now I will ask this question, what is your observation? See, it is divided, the graph paper is divided into squares of 1 centimeter side. See, so these are the squares. Big square, of course, big square having 1 centimeter side. Then that's why I have mentioned here it is divided into squares of 1 centimeter side. Then you see 1 centimeter side is further subdivided into 10 equal divisions in terms of millimeter. See, so the square having 1 centimeter side, again that 1 centimeter side is subdivided into 10 equal divisions in terms of millimeter. So this should be your observation from the graph paper. Of course, you must be acquainted with this. Still, I am just convincing you all. So how do you use the graph paper before you plot a graph? Well, after looking the graph paper, you see one more picture of a real graph sheet. So what do you see in this graph sheet? So what is your observation in this graph sheet? You see, in Cartesian coordinate system, deliberately I am using the word Cartesian coordinate system because you are familiar about the Cartesian coordinate system in mathematics. That's why in Cartesian coordinate system, you see two perpendicular axes. One is x-axis, horizontal axis, then the other is the vertical axis, that is the y-axis. That's why see this real graph sheet on which the horizontal line is the x-axis and the vertical line is the y-axis. So you see the x-axis and y-axis are two perpendicular lines in the Cartesian coordinate system, you remember, crossing each other at a point O. See the point. They are crossing each other. X-axis, Y-axis are crossing each other at a point O. So this point O is called the origin. The coordinate of the origin 0, 0. First 0 is the x coordinate, the second 0 is the y coordinate. The coordinate of the origin is 0, 0. Well, you see in the graph sheet there is markings on the x-axis and y-axis. You see the axis, x-axis, right side 1, 2, 3, 4, 5. These are the markings. And again on the left side there is -1, -2, -3, -4. Similarly, there is markings on the y-axis. So this should be your observation from the real graph sheet. Well, let us ask this pertinent question. What is meant by graph? That is the question. Because we are familiar with the graph and we are going to plot the graph and we are going to represent the linear motion graphically. So first of all, we should know what is meant by graph. Can you answer me this question? Well, a graph is a geometrical figure. You must have drawn the graph with the help of a graph sheet. Bar graph you might have drawn. So that is a geometrical figure which shows the relationship between two quantities plotted on x-axis and y-axis. First of all, it is a geometrical figure. Maybe a line, maybe a curve. So the geometrical figure that shows the relationship between two quantities. Why two quantities? One quantity you will plot against x-axis, the second quantity you will plot against the y-axis. Therefore, what is meant by graph? Now please tell me. Well, a graph is a geometrical figure which shows the relationship between two quantities plotted on x-axis and y-axis. For example, the position of an object is changing with time. So what are the two quantities here? One is the position of the object, the second one is the time. So you need to plot the graph of these two quantities, such as position of the object, then time. So you have to take time in one axis, say on x-axis, then position of the object in other axis, say on the y-axis. So therefore, it is a geometrical figure which shows the relationship. That means whenever the position of the object changes with time, then that will show the relationship. So how that position of the object is changing with time. Is it not interesting, students? Yes, very nice. Then let us see how to choose the axis before plotting a graph. So is it not the first job before plotting a graph? Yes, we need to choose the axis. So how do you choose x-axis? How do you choose y-axis? So choosing the axis before plotting the graph is very, very important. So what do we need to do? We have to identify the quantities. Identify the independent variable quantity or the physical quantity. Then we need to identify the other physical quantity or dependent variable or dependent physical quantity. So that is a very important task. For example, as I mentioned just now, the position of the object is changing with time. So in this case, these are the two quantities. What are those? One is time and the other one is the position of the object. If time is one quantity, position of the object is other quantity. So first of all, we need to identify which is independent physical quantity and which is dependent physical quantity, or which is independent variable, which is dependent variable. Well, in this particular example, time is an independent physical quantity. Why? Because the position of an object always depends on time. Since the position of the object depending on time, so time is an independent physical quantity or independent variable, and the position of the object on the other hand is a dependent physical quantity or dependent variable. because the position of the object is essentially depending on time, but time is not depending on the position of the object. Am I right, students? So therefore, first of all, before plotting the graph, we have to identify the independent variable or the physical quantity and dependent variable or other physical quantity. Then after identification of the physical quantities, then we have to, take the independent physical quantity or independent variable on the x-axis and dependent variable or dependent physical quantity on y-axis. But remember students, scale is very important. That's why with a suitable scale, we have to take the independent variable along the x-axis, dependent variable along the y-axis. So here the example, as I mentioned, position of the object is changing with time. So time is independent physical quantity, position of the object is the dependent physical quantity. So here you need to take time along the x-axis and position of the object, which is the dependent physical quantity, so that should be taken on the y-axis with suitable scale. So this is very, very important thing you have to remember before going to plot a graph. Well, students, so can you identify this graph? Can you identify? Well, you see, the time is taken along the x-axis. Time is independent physical quantity. Distance covered by an object, because the object is in motion. Distance covered by an object is taken along the y-axis. And the graph you see, it's a straight line and passing through the origin. Now I have the question, identify the graph. So what is the name of this graph? Can you tell me, students? You must be very curious. Yeah, your answer is 100% correct. It is distance versus time graph. The name of the graph is distance time graph. So that is the second learning point today, that is the distance time graph. So this is the distance time graph. Well, so what do you observe from this graph? See very carefully. So origin is O and the coordinate of the origin is 0, 0. On the x-axis, it is time in minutes, 20 minutes, then 40 minutes, then 60 minutes. See equal interval of time of 20 minutes. See along the y-axis, it is distance in kilometer, unit is kilometer. So first 10 kilometer, then 20 kilometer, then 30 kilometer, then 40 kilometer. It is divided into equal interval of distance of 10 kilometer. So now what you observe on this graph, you see the independent physical quantity is the time. Am I right, students? Okay. So the independent physical quantity, time, is taken along the x-axis in minutes. I have already explained about this thing before you plot a graph. With one smallest division of 2 minutes. See, one smallest division from the origin O, one smallest division, so that is 2 minutes along the x-axis. Then the dependent physical quantity is distance, that is taken along the y-axis in kilometer. See, it is in kilometer. Then one smallest division of y-axis is 2 kilometer. See once again, one smallest division on the y-axis is equal to 2 kilometer and one smallest division on the x-axis is 2 minutes. So after observing this graph, distance time graph, then you see what is the nature of the graph. That is very essential. That is very, very important. Am I right, students? The nature of the graph is a straight line. Am I right? Or linear. If the nature of the graph is a straight line, you can say it is linear. Then it is passing through the origin. It is passing through O. So what does it show? It shows that the object is in motion. Why motion? Because there is change in distance with time. If there is change in distance with time, then the object must be in motion. So therefore, this graph shows that the object is in motion. It is mentioned as because the position of the object is changing or the distance of the object is changing with time. Then if you observe carefully, then you notice there is equal change in distance in equal intervals of time. See once again, distance time graph. Distance is changing with time. Then there is equal change in distance with equal interval of time, because the nature of the graph is a straight line, linear, and passing through the origin. So if you observe this nature of the graph, which is basically linear and passing through the origin, then what would be your concluding remark? The concluding remark must be about the motion of the object. Here the motion of the object is uniform motion, is in uniform motion. Why? Because I have already taught you, I have already explained you with activities, with conceptual questions, and with different examples under which situation the motion of the object is said to be uniform. So here the motion of the object is uniform as it covers equal distance in equal intervals of time with constant speed. So here you see the distance time graph, then you guess the motion of the object. I have already explained that the motion of the object must be uniform motion. So in uniform motion, so there is equal change in distance in equal intervals of time, and the object moves with constant speed. So this is all about the nature of the graph and the nature of the motion involved in this graph. Then I will ask one more question here. As I have explained, this is distance time graph, and how do you find the speed from the graph? Because I have already explained, in uniform motion the object should move with uniform speed or constant speed. Then obviously the question is, how do you find speed from the graph? See, distance is along y-axis, time is along x-axis, and we have to find out the speed. From the definition of speed, we have already learned that speed of an object is the distance traveled per unit time, or speed is equal to distance divided by time. So if it is distance divided by time, then you see there is a right angle triangle. ABC is a right angle triangle. We have taken 2 points A and B on the graph, straight line graph. Through these 2 points we have taken the right angle triangle ABC. In the right angle triangle ABC, tan theta, from mathematics you must have learnt about the tan theta, sin theta, cos theta, cot theta. Here in ABC right angle triangle, tan theta is equal to perpendicular divided by base. So what is the perpendicular in this case, in this right angle triangle? BC. BC is the perpendicular. And what is base in this right angle triangle? AC. AC is the base of the right angle triangle ABC. So tan theta is equal to BC divided by AC. So what is BC? So B, if you see BC, so these are the 2 points, or the line corresponds to the distance on the y-axis. So BC is the distance. Then what is AC? AC is the difference of time t2 minus t1. So AC is the time, difference of time t2 minus t1, say t, and BC is the distance, s2 minus s1. So then obviously tan theta is equal to BC divided by AC is equal to distance by time. So if tan theta is equal to distance by time, then the speed, is equal to distance by time. So speed is equal to tan theta is equal to distance by time is equal to slope of the distance time graph from ABC right angle triangle. So in this graph, the distance time graph is a straight line passing through the origin. Then the slope of the graph is the speed of the object moving in uniform motion. Alright students. So then finding speed from the distance time graph. I have already explained this thing. So how do you find speed from the distance time graph? So from the slope we can find the distance time graph. So what is that slope? Tan theta. Nice. So slope tan theta of the distance time graph gives the speed of the object. Then if the slope is constant, the speed of the object is constant or uniform. So then you please see in this graph, distance time graph, slope is constant or variable. What is your answer? Is it variable? No, not at all. Slope of distance time graph in this case is constant. So if the slope of distance time graph is constant, then the speed of the object is constant or uniform. So do you understand about the concept of speed from the slope of the distance time graph? Well, so it is very easy to find from the distance time graph. Well, students, I am putting a question before you for your guesswork. Can you guess the nature of the distance time graph of non-uniform motion of an object? Mindfully, please read this question. Non-uniform motion of an object. We have already explained about the uniform motion of the object. In the uniform motion of the object should travel equal distance in equal intervals of time. But in non-uniform motion, you must be knowing that the object must travel unequal distance in equal intervals of time. Now, I have the question like, you need to guess the nature of the distance time graph. In the case of the uniform motion of an object, the nature of the distance time graph is straight line or linear, isn't it? Now, you please guess the nature of the distance time graph of the nonlinear motion of the object. So can you guess? Is it a straight line? No, not at all. Then you just, take the example of distance traveled by a toy car at regular interval of time through this table. You see the table. Can you see two columns on the table? Okay. What is there in the first column? Time taken by the toy car in seconds. What is there in the next column? Second column. Distance covered by the toy car in meters. So distance in meters against time in second. So that has been given in this table. So therefore, it is mentioned distance traveled by a toy car at a regular interval of time. See the data. Before you go for plotting a graph, you have to see the data. So whenever the time is 0 second, distance is 0, that means the object is at rest. Whenever the time is 2 seconds, the distance covered by the object is 1 meter. Whenever time is 4 seconds, the distance covered by the object is 4 meter. When the time is 6 seconds, distance traveled by the object is 9 meter. When the time is 6 seconds, then the distance 9 meter. Then whenever the time is 8 seconds, distance covered by the object is 16 meter. Whenever the time is 10 seconds, distance covered by the object is 25 meter. Whenever the time is 12 seconds, distance covered by the object is 36 meters. So after observing this table, you need to go for plotting a graph, because we are going for distance time graph. In the case of uniform motion, we have already plotted the graph. We have already witnessed the graph. We have seen the graph. It is a straight line. Okay. Now, here it is an example where distance of the object, that is the toy car, is changing at a regular interval of time. If you plot the graph, Then what would be the nature of the graph? What is this graph first of all? Again, distance time graph of a toy car. Because this particular table is represented graphically by the help of the distance time graph. So this graph shows the relationship between two physical quantity, distance and time. Distance is the dependent physical quantity or dependent variable. Here time is the independent variable. So if you plot the distance time graph of a toy car, you know how to plot the graph. I have already told you. You have to choose the axis, x-axis, y-axis. Then you have to put the independent physical quantity, dependent physical quantity on these two axes. Then take the coordinate. You have to take the x coordinate. You have to take the y coordinate. Then put this x coordinate, y coordinate on the graph sheet. You see, you will find a graph of this nature or this type. This is a distance time graph of this particular table. So then I will ask you the question, go for analyzing this graph. If you unless until you analyze the graph, you cannot understand the nature of the motion. You cannot understand how the motion is taking place. So that's why whenever we plot a graph, we need to go for its analysis. Am I right, students? Any graph whenever you plot, maybe straight line, maybe a curve, maybe a parabolic curve, maybe exponential curve, whatever curve it may be, you need to analyze the graph. That is very, very essential. So you see from the graph that the nature of the graph, is it, linear? What is meant by linear nature? Straight line. Am I right? Is it straight line? No, not at all. Then what is the nature of the graph? Non-linear nature of the graph. That is, it is a non-linear curve. It is a curve, non-linear curve. So non-linear nature of graph. So slope, if you see, because I have already told you slope. What is that slope? Slope must be tan theta. So here you see slope are two different points, a tan theta 1 and tan theta 2. See, theta 1 is greater than theta 2. So obviously tan theta 1 is greater than tan theta 2. So since tan theta 1 is greater than tan theta 2, then obviously the first slope, that is tan theta 1, is greater than the second slope, that is tan theta 2. So slope is non-uniform in this case. I am repeating once again, nature of the graph is non-linear, slope is non-uniform, that means not constant, it is variable. Once again you see, so if you go down, you find the slope is gradually decreasing. So that's why the slope of this graph is non-uniform. So what would be your interpretation about the motion of the toy car? Toy car moves in non-uniform motion with variable speed. Why variable speed? As I have mentioned, slope tan theta is equal to the speed. Here the slope of this curve, nonlinear curve, is variable. That's why object, here is the toy car, moves in non-uniform motion with variable speed. And whenever it is variable speed, we know from our earlier discussion, it should cover unequal distances in equal intervals of time. So toy car covers unequal distances in equal intervals of time. Then the motion of the toy car is non-uniform. So please see the table once again. Time interval same, 1 second, 0 to 2 seconds, then 2 to 4, 2 seconds. So time interval is 2 seconds. Now distance in meter, intervals you see, unequal distances covered by the toy car in regular intervals of time. So therefore, the motion of the toy car is non-uniform. Well, after discussing this concept, that is distance time graph, so let us do this activity. So see, this activity is with the graph sheet. You take a graph sheet and plot distance time graph using the following table. I have given two tables. You see, it is there in front of you. Table 1 and table 2. And find velocity and acceleration of the object. Because you know the concept of velocity, you know the concept of acceleration from your previous knowledge. Do this activity. With the help of these two tables, plot two different graphs. Then from the graph sheet, you find out the velocity of the object and also find out the acceleration of the object. If you look the table carefully, time mentioned in the first row, it is not column, first row, 0 second, 1 second, 2 second, 3, 4, 5 second. And distance s is the distance in meters, 0 meter, 2 meter, 1 meter, 2 meter, 3 meter, 4 meter, 5 meter, 6 meter. And in table 2, similarly distance is mentioned in the second row and time is mentioned in the first row, 0 time, 0 distance, 1 second time, 0.5 meter distance, then 2 second time, then distance covered by the object is 1 meter, and so on. So you have to plot the graph. Then you analyze the graph, then you have to find out the velocity of the object and acceleration of the object. Well, students, you understood the first concept or the first learning point, graphical representation of the linear motion of the object, and I have shown you the graph. I spoke how to choose the axis of the graph, how to choose the independent and dependent variable, independent or dependent physical quantity, then how to plot a graph. Then I have already discussed about distance time graph. In the uniform motion of the object, which is a straight line, non-uniform motion of the object, which is a nonlinear curve, not a straight line. And I have already explained how to find out the speed of the object from the slope of the graph. Am I right, students? You must have enjoyed the topic, enjoyed the concept, no? Okay, so if you do this activity, then you will enjoy more. Well, students, let us, stop here. Then in the next class, we'll discuss about velocity time graph and we'll discuss about distance moved by the object from the area under velocity time graph. Okay, students, thank you so much.